Assalamualaikum and a very good day to you all. In this video, I would like to share with you about second order partial differentiation. So if you watch my video about first order partial differentiation, we know that if we have a function z and then we differentiate this function with respect to x, okay, we get delta z delta x. And if we differentiate this function with respect to y, okay, and then we get delta z delta y. These two are the first order partial differentiation. We can continue this further. So I think I put it over here better. Okay, we can continue this process further. Okay, so I can copy these arrows. Okay, copy and then put it here. Okay, it's just that I changed the inside lah. Okay, first okay, so this one means we differentiate delta z delta x. So what happened if we already differentiate z with respect to x? We get delta z delta x, and then we differentiate delta z delta x with respect to x. Okay, so we get delta 2z delta x squared. Okay, and we do the same process, okay, for delta z delta x, but this time we differentiate it with respect to y. Okay, so what we get is delta squared z delta y squared. Okay, done with that one. This one we haven't, so we can paste over here. Alamak, tamat. If that's the case, we can move this one a little bit further, like that. This one like continue like that lah. Okay, so I rub this off. Okay, this time we want to differentiate delta z delta y with respect to x. So what we get is delta squared z delta why I made a mistake. I made a mistake. I'm so sorry. For this one, it's not delta z delta y. Okay, it's this function delta z delta x. Okay, so for this one we will get delta squared z delta y delta x. Okay, good. Now this one we get delta x delta y. Okay, this one it's look alike, okay, but we will go into this one later. Let's finish this one first. Okay, how about this one? We want to differentiate delta z delta y with respect to y. So what we get is delta squared z delta y squared. Okay, now these two, please do not mistake these two, okay, because this one means we differentiate z with respect to x first, then with respect to y. That's why you see the order is a little bit another way around, isn't it? You thought you read delta y first means we differentiate z with respect to y first, but it is not. Okay, because the way of writing is like this. We do the bracket composite. It's like doing a composite function. Okay, now for this one, for the one that I make a green box, okay, it means that we differentiate z with respect to y first, okay, then we differentiate the function, the first derivative, with respect to x. Okay, so please do not get the mixed up. Okay, so this is the first family tree, I suppose. Okay, so you can use this family tree. You can put this in your notes and then you refer. Okay, when next time you see the questions, and then you know which one is which. Okay, otherwise we get confused. Okay, this is the first one. The second one, if we consider z, and then we want to write it as z sub x. Okay, this one means that we differentiate z with respect to x lah. Okay, why I do this color? No. Okay, I just copy paste the branch lah, right? Okay, paste. Easy. Okay. So this one is z sub x. Okay, we can continue this further. Okay, and then over here, this direction, we get z sub x. Okay, and then we go this direction, z sub x. X first, Okay, then z. Y. Sorry. Y, right? Okay. Y. Okay, and then let me paste this one first. Okay, so this one, if we go this direction, we get z sub y. Okay, and then we continue further to this direction, we get z sub y x. Okay, now we go this direction, z sub y. Okay, Allah, sorry, wait, I rub them off for you to copy it easily. Okay, done. Okay, so this is another example. So this is another way of writing it. So as you can see here, if we write like this, z sub xy or z sub yx, this one, the way we read it is the same thing as the order of the differentiation. Okay, for example, zxy means we differentiate, zxy means we differentiate with respect to x first, then y. Okay, same goes to z sub yx. Y, you see here, y, right? And then x over here. So y first, then we go through here, x, and then we get this one. Okay, so please take note the way of writing. If you want to write like this, or the question requires you to, then you have to refer to this family tree. For this one, I don't think so, because it's straightforward from way of writing, we know already. Okay, so I think maybe one example. Okay, this one. Okay, so given fxy equals x cubed 4xy squared plus 15, find fxx, fyy, fxy, fyx. Now, first thing first, we have to find f sub x lah. Okay, so this one, x squared plus 4y squared, because the variable is x, and then plus 15, 0 lah. Okay, and then we find f sub y. F sub y is this one becomes 0 plus y, right? So we get 8xy and then 0. Okay, now from fx and fy, fx we can get f sub x. From f sub x we can get f sub xx and f sub xy. So we do that one first. So fx with respect to x, we can get f sub x. So what we get is 6x 0 lah. Okay, and then this one done, this one pula. So fxy means we differentiate with respect to y. So we get fxy. So with respect to y, this one is 0, this one is 8y. Okay, now let's continue with f sub y. From f sub y, I make it smaller. We can get fyy and f sub yx. Okay, f sub y we differentiate with respect to y. We get f sub yy, which is, this one is the variable, right? So 8x. We can do further by differentiating with respect to x to get sub yx. Okay, sub yx means we differentiate f sub y with respect to x. Okay, so this one 0, nothing lah, padam lah. Okay, and then we differentiate 8xy with respect to x. So this is the variable. So 8 and y are the constant. X becomes 1. 1 multiplied by 8y is 8y itself. Okay, so I think that's all. Thank you for your time and attention. Assalamualaikum. Have a good day.